Maps and Globes by Jack Knowlton. Thousands of years ago, our ancestors invented the map. Ancient maps were crude but very useful tools. They helped people find food, clean water, and the way back home, even when home was a deep, dark cave. As civilizations grew, better maps were needed. The oldest existing maps are from the ancient desert kingdom of Babylonia. These maps were etched on tablets of damp clay that soon baked rock hard in the midday sun. Early Chinese map makers painted beautiful maps of their empire on pure silk cloth. People in every part of the world cleverly used local materials to make the maps they wanted and needed. Charts are maps used to sail the wide ocean. The Polynesian islanders sailed the vast Pacific Ocean using stick chart maps. These charts were woven with reeds and palm leaves that showed the ocean's currents and wave directions. Seashells were attached to each chart to indicate the larger islands. But ancient world maps were incredibly incomplete. Until a few centuries ago, the Earth was neither fully explored nor accurately mapped. As a result, these maps presented a world that looked like this, an incomplete and very incorrect world. At this time, most people still believed that the Earth was as flat as a pancake. If it really was flat, then ships and sailors might tumble over the edge if they sailed too far from dry land. The age of exploration begins. Columbus sails. About 500 years ago, some big changes were in the wind. Brave sailors and map makers were beginning to sail farther and farther from the safe shores of Europe. The true shape, the true look of the Earth was about to be discovered. Realistic, dependable maps would soon follow. When Christopher Columbus sailed west in 1492, he was actually looking for the Spice Islands of India. He wanted to discover a safe, short ocean route from Spain to India and back again. What he really found proved to be two unmapped continents, North and South America. Magellan sails and proves that the Earth is round. In 1519, Ferdinand Magellan sailed from Spain with a fleet of 5 ships. Magellan wanted to be the first explorer to sail all the way around the world. If the voyage was successful, it would prove to one and all that the Earth was round. The fleet sailed down through the icy waters at the tip of South America, across the Pacific and Indian Oceans, around Africa's Cape of Good Hope, and back to Spain. After 3 long years at sea, one battered surviving ship had completely encircled the Earth. An explosion of discovery and exploration was soon underway now that all were convinced that the Earth was round. Like an orange. Like a cannonball. Like a globe. Globes are tiny models of our Earth. Globes, unlike flat maps, are shaped exactly like the Earth, like a ball or sphere. They are very tiny models. The Earth is really 30 to 40 million times bigger than the globe in your classroom. Globes, because they are round, put all the world's geography in its proper place. They give the truest possible view of the whole Earth. Maps put our round Earth on flat paper. Maps are precisely drawn pictures of the Earth, pictures of the entire Earth, or any part of it. There are maps of the world, maps of the country, where you live, and maps of your hometown. Maps put all the wet oceans and all the lumpy, bumpy land on sheets of nice, flat, dry paper. Globes are the most realistic world maps. Since globes duplicate the true round shape of the Earth, all distances, directions, sizes, and shapes are true to scale on globes. But maps must artificially flatten the real round world, so map makers cut, stretch, and distort some parts of the Earth to get it all flat on paper. The worst map distortion is at the top and bottom of the world, in the Arctic and Antarctic. Greenland, for instance, looks bigger than all of South America on a flat map, but it isn't. A globe instantly shows that South America is really much bigger. In fact, it's 8 times bigger. Maps have a language you can learn. Maps and globes can take you places and show you things when you know how to read them. Map language is partly names and numbers. It's also bright colors, great circles, imaginary lines, and tiny symbolic cartoons. Map language begins with the 4 basic directions. Direction means which way. North is the direction toward the North Pole from any other place on Earth. South is just the opposite. It's always toward the South Pole. East is the direction where the sun appears every morning, and west is toward the sunset. The equator divides the Earth in half. The equator is a great imaginary line around the middle of the Earth. It divides the Earth into 2 equal parts, the northern and the southern hemispheres. A hemisphere is exactly 1/2 of a sphere. The northern hemisphere is the half that's north of or above the equator. Most of the world's dry land and most of its people are within this area. The southern hemisphere is everywhere south of or below the equator. Of the 7 continents on Earth, only 2, Australia and Antarctica, are completely within the southern hemisphere. How to put big countries on small pieces of paper. Distance is how far apart places are. Maps and globes miniaturize the actual distances they are drawn to scale. Scale is the system that reduces the real land, the real oceans to sizes that fit on paper. Scale lets you hold millions of square miles in your own 2 hands. To find distances on this map, measure the inches with a ruler and multiply by 500. The map distance between San Diego and Boston is about 5 inches, so the real distance is about 2,500 miles. You can measure the Earth with a piece of string. Globes differ in size, so they differ in scale. The exact scale of any globe is shown in its key or legend. To find mileage on a globe, first measure the inches with a string, then multiply by the scale. For instance, the shortest jet route from Chicago to Calcutta, India, would be due north over the North Pole. This great circle route is a long curving distance of about 8,000 miles. Where on Earth am I exactly? Maps use a network of intersecting imaginary lines to identify the exact location of every place on Earth. This network builds from 3 locations that we already know: the North Pole, the South Pole, and the equator. Latitudes, or parallels, tell how far north or south. Lines of latitude are drawn parallel to the equator. They measure the degrees north or south of it. The equator itself is a 0 latitude. It's exactly in the middle. Longitudes, or meridians, tell how far east or west. Meridians are imaginary lines running vertically from the North Pole to the South Pole. East and west are measured in degrees from the Greenwich or prime meridian. How high are the mountains? Elevation means how high. Elevation tells you the altitude of any place on land: mountains, valleys, deserts, and glaciers. Elevation is measured from sea level. Sea level is considered zero elevation. Map makers combine colors and contour lines to highlight the location, shape, and elevation of especially high places. The highest place on Earth is Mount Everest in the Himalayas. Its peak is 29,028 feet above sea level. How deep are the oceans? Depth means how deep or how far it is from the bottom. Depths are measured from sea level, zero depth, straight down to the bottom of the ocean, the sea, the lake. Map makers use contour lines and several shades of blue to show the depths and features on an ocean floor. There are more mountains and volcanoes under the oceans than on dry land. Deep canyons split the ocean floors. The deepest, the Mariana Trench, is 36,198 feet below sea level. That's about 7 times deeper than the Grand Canyon in Arizona. Physical maps, the nature of places. There are many kinds of maps. Each provides a different type of information. Physical maps present the works of nature. They show the vegetation, terrain, and other natural features of such places as jungles, deserts, and open grasslands. Physical maps show the elevation of the terrain. They also note the depressions, which are areas of land that lie below sea level. Political maps, people and countries. There are over 150 independent countries or nations on Earth. Political maps show the capital cities and the boundaries between countries. Boundaries or international borders reflect the political divisions that people have agreed to. Some borders are straight lines plotted by surveyors. Other borders follow natural features. Some run along the highest peaks in a mountain range. Still others are plotted precisely down the middle of large rivers, so that each country gets one riverbank and precisely one half of the river. Local maps, getting closer to home. Local maps show you smaller areas. Each gives a detailed close-up look at a community and its environment. Local maps show the familiar natural features, the forests, the rivers, the sandy beaches. They also show the landmarks, the special features that are big, easy to see, and easy to remember. Local maps also show the cultural or man-made features in a community. Cultural features are the visible evidence of human work and activity upon the earth. They include highways, school buildings, wheat fields, and airports. There are many ways to see Arizona. Many maps provide general information about an area's geography. They give us an overview of its landscape, landmarks, and features. Other maps present specialized information about a place. They focus on a single topic at a time. A few of these topics are population, climate, history, and wildlife. The world is waiting for you. If you take a fancy to any place on Earth, you can go there today and still be home in time for dinner. Just walk into a library, open up an atlas, and fly there in your imagination. An atlas is a book full of maps. It's your personal passport to our wide world. There's a collection of atlases in every library in the land. Their Dewey Decimal Number is 912. So open a map or spin a globe. The wide world awaits you.